The function f is defined by the function equals 2 minus 5 over x plus 2, so it's an inverse function, and x is only valid, so the domain is x is greater than negative 2. Of course, if x equals negative 2, it's undefined because you have negative 2 plus 2 is 0, and you can't divide by 0. Okay, so we have to state the range, which is all of the valid y values for this, and you're meant to be able to think this one out. And so let me help by drawing some things. To think this out, we we want to have a look at what happens as we approach the two boundaries. And the two boundaries are at negative 2. So I'll draw a little diagram for you. This is the y-axis, this is the x-axis, and this is x equals negative 2. And of course, x can't be negative 2, but we are talking about every value of x which is to the right of that line. Okay, so we want to find out, well, what happens as we get closer to infinity? That's the easy one. As we get close to infinity, as we get close to the line, there are two things we want to know. That's going to help us determine the range of the function. Well, as we go to infinity, that means x gets really large. Well, x plus 2 gets really large. And if x plus 2 gets really large, we're dividing a fraction by a really large number, which makes a really small number. The larger that number on the bottom gets, the smaller the fraction gets. So it approaches 0. So we end up with 2 minus 0 is just 0. So as this is what our head is doing, right? As x approaches infinity, y is going to approach 2. So that's going to be the maximum that we're going to get to. All right, the slightly trickier one is, well, what happens as we get closer and closer to the line x equals negative 2? So what's happening here is we're going to have a negative number plus 2, and it's going to become, when you add the 2, it becomes positive, and it's just going to become a smaller and smaller positive number. So the bottom of that fraction is going to approach 0 from the positive side. Now, as a fraction approaches 0, you divide by a smaller and smaller number on the denominator, the whole fraction gets larger and larger and larger. The smaller the number you divide by, the larger the result of the fraction is going to be. And so the whole term, let's just say it's 5 over x plus 2, as x approaches negative 2, the denominator is going to become extremely small positive number, which means the whole fraction is going to become an extremely large number. But what are we doing with that fraction? We're dividing by, we're subtracting it from 2. And so as it's an extremely large number that we're subtracting by 2, that number is going to become, the whole value for y is going to approach negative infinity. So what does it look like? It looks like negative infinity here. As x goes to positive infinity, we approach 2, and it's going to look like that part of an inverse function where it's going to 2. The simplest way to state the range is to say that y is going to be less than 2. We're done. Right, for part B, we need to obtain the expression for the inverse and state the domain of the inverse. The domain of the inverse is going to be the range of the function because they're just flipping, and so we already know the domain. Part B, we are going to start out by changing the x and y variables. So instead of y equals 2 minus 5 over x plus 2, we're going to say x is equal to 2 minus 5 over y plus 2. That's effectively the inverse function. Not written very nicely, but we want to rearrange it so we have y equals something, and then we actually have the inverse function. Okay, so let's take the minus the whole fraction over to the other side, and we would get 5 over y plus 2. And let's take the x over to the other side, and we'll get 2 minus x. They effectively swap places. The y minus 2 can come up and multiply by the 2 minus x, and the 2 minus x can go and divide by the y minus 2. And so we'd end up with y plus 2 on top is equal to 5 over 2 minus x. All right, so I brought the y minus 2 up onto the other side, and I took the 2 minus x down under the 5, and then I just wrote it on the different sides straight away. That leads us with y is equal to 5 over 2 minus x minus 2, and that's our inverse function. So we would say f inverse x is equal to 5 over 2 minus x minus 2, and we know the domain because it is the range of the previous function, where y is less than 2, so in this case, x is going to be less than 2. And we're finished part B. Moving on to part C, we are told the function g is defined by, it's a straight line, gx is x plus 3 and x is greater than 0. You can pay attention to that. C, obtain the expression for, let's put gx, the function g, into the function f, giving your answer in some form, and all those values are integers. Okay, so we should check that the range of gf, because the domain is x is greater than 0, the range is going to be y is greater than 3, fits into the domain for f, because we're putting g into f. And yes, f was x is greater than -2, and all the values, all the y values from gx are valid. So we don't have any problem with this, and if you didn't know that, you could just do it and still get away with it. All right, so our function, let's bring our function x back into view, and we'll have 2 minus 5 over x plus 2. All right, so that's the function f, and what we're going to do is we're going to put g into that, and as soon as we do that, we get f gx is equal to, instead of x, we're going to put g, and we'll get 2 minus 5 over x plus 3 plus 2. Of course, where we saw the x, we put the whole of the function g. So now we just have to rearrange it to make it look like a single fraction. And we'll make this simpler at first. We've got 5 over x plus 5. All right, so to turn it into a single fraction, we need to turn that 2, which is by itself, into a fraction with the same denominator. So we're going to multiply 2 by x plus 5 on x plus 5, and we'll get 2x plus 10 over x plus 5 minus 5 over x plus 5, and we're almost done. 2x plus 10 minus 5, we add the top, remember, for fractions, and we'll get plus 5, and on the bottom we'll have x plus 5 because it stays the same. All right, we are finished. Maybe we should just write what a, b, c, and d are. Maybe we don't have to, but it just could be nice to do that. So a is 2, b is 5, c is 1, and d is also 5. And that's the end of the question.